everything around us relies on a hidden architecture. Atoms constantly interact, desperately chasing that perfect, stable electronic harmony.
When metals and nonmetals meet, they don't just bump into each other. They trade electrons, forging intense ionic bonds.
This atomic theft creates a crazy imbalance. You get positively charged cations and negatively charged anions from the exchange.
And opposites attract, right? This relentless electrostatic force creates an ionic bond, locking these charged particles together. The result is a massive, rigid lattice of alternating ions. Breaking these tight bonds takes some serious thermal energy.
That's why compounds like salt melt at insanely high temperatures. Now, as solid crystals, they can't conduct electricity,
'Cause their ions are completely stuck. But if you melt them down or dissolve them in water, everything changes.
Suddenly, those freed ions surge, easily carrying electrical currents. But hey, atoms have another trick, sharing electrons to survive.
We call these covalent bonds. Think about water, ammonia, or methane. Atoms here tightly share their outer electron layers.
Inside the molecule itself, the bond is absolutely ironclad. But the forces between different molecules? Actually incredibly weak.
So because they barely hold on to each other, they melt really easily. Plus, without any mobile charged particles,
They literally can't conduct electricity. But what happens when covalent bonds scale up into massive, vast networks?
We get giant covalent structures. Take a diamond. It's a relentless 3D grid where every carbon bonds to 4 others.
This rigid lattice makes diamond the hardest natural material around. But graphite uses those exact same carbon atoms differently. In graphite, each carbon bonds to just 3 neighbors. This creates sprawling, flat sheets of 2D-linked hexagons.
These flat layers barely interact. They easily slide right past each other, making graphite a perfect, slippery lubricant.
Meanwhile, those free-roaming, delocalized electrons between the layers make graphite an incredible electrical conductor. Pretty wild, right?
And this isn't just for carbon. Silicon dioxide, basic sand, builds a harsh, high-melting microscopic grid, much like a diamond.
Finally, let's look at metals. Their structural integrity comes from a massive lattice of positive ions entirely submerged in
a fluid sea of delocalized electrons. This invisible flowing electric ocean is why copper wires conduct power so effortlessly.
Smash a metal, and the layers just slide. That flowing electron sea holds everything together, making metals incredibly malleable. So, from unbreakable diamonds to highly conductive wires, these microscopic atomic architectures act as the fundamental, invisible rules that literally dictate the physical reality of our universe. So what invisible structures are hiding in your hands right now?